Good morning, everyone, and welcome to the second in our webinars as part of BSBI's Irish Aquatic Plants project, sponsored by the National Parks and Wildlife Service. Today, Nick Stewart will be introducing us to stoneworts and how to identify them. I'm Sarah Pearce, BSBI's Ireland officer. Also with us behind the scenes today is Claudia Ferguson-Smythe, an aquatic plant specialist and also joint BSBI referee for care fights. She'll be helping to ask questions as we go along. Those who joined us for last week's introduction to aquatic plant ID will know that Nick is an aquatic plant expert who's been looking at aquatic plants since he was a child. He's done extensive survey work across Britain and Ireland for organizations such as the Environmental Protection Agency and the National Parks and Wildlife Service and many others. He's also a wonderful trainer. He's done loads of training for the Field Studies Council, for BSBI, and for other organizations. So I'm sure he'll have a great session for us today. And without further ado, I'll hand over to Nick.
Good morning. Today I'm planning to introduce you to a very interesting group of aquatic plants called stoneworts. Also, some quite often known as charophytes. The two names are used interchangeably, and you may find me swinging from one to the other during this talk. What a rough plan of what we'll be looking at today. First of all, a bit of an introduction as to what stoneworts are and how to recognize them. A little book on books and keys, but the main body of this talk will be looking at characters for identification and how to go about identifying them. I'll finish up with a little bit looking at habitats and threats to stoneworts. So to start with, what are stoneworts? They are a group of very specialized, complex algae, mostly freshwater, a few in brackish water, but not marine. And they vary very considerably in size. There are some just a few centimeters tall, like this one here, to some which are over a meter in length, and when they grow in dense masses, they form a very sort of considerable bank of vegetation with a very large biomass. And it's because of this sort of size and complexity that they have a sort of an honorary status among the higher plants. They're the only group within the remit of the Botanical Society of Britain and Ireland, and probably that dates right back to the early days of the Botanical Society, and I think that it was due to a name that would be familiar in Ireland, Alexander Moore, but when he was living in the Isle of Wight, he found the foxtail stonewort, and that caused quite a stir, and I think at that point he was sort of friends with the leading lights in the Botanical Society, and I think from then on they thought, well, why don't we look at these too? And in fact, they tend to be looked at more by higher plant botanists than they do by algologists who are more used to looking down microscopes. They are also included in the group of plants called aquatic macrophytes. So they're used in the monitoring of vegetation in lakes and rivers, particularly for things like Water Framework Directive and some protected sites. And as we'll come to later, they are particularly sensitive to water pollution. So recognizing a stonewort, as I said before, they're quite variable in size, but some of them are extremely large. All of them have these whorls of what might superficially be look like leaves, but I'm afraid because they are a rather unique group, they have a few terminology that will be unfamiliar with you. I'll try to keep those to a minimum, but we will come across. And one of the ones I would just like to introduce at this stage is the branchlet, which is what these regular whorls are called, as opposed to the branches, which are where the stems fork. But these sort of things that look a bit like leaves, sort of linear leaves, the term is branchlets, and they're always in whorls of usually around about 8. And the general appearance is, for certainly for the main group, which is the Charas, is rather like a horsetail. And indeed, way back in Ray's time, they were originally classified with the horsetails, called stinking water horsetail in Ray's book. But subsequently, the reproductive structures showed that they were definitely algae. Some have sort of simple branchlets like this. Some of them are quite forked. So for those of you that were watching my talk on aquatic plants and the different leaf forms, you would either put this either in the stringy category, those with undivided leaves, or because the little extra things, these are actually bract cells around the fruiting structures, you might call this feathery, and there are other ones which have more forked branchlets, which are definitely looking much more feathery. So you would either put them in the stringy group or in the feathery group. Some of them have a distinctive smell. The smell is different people have different interpretations. Some garlic, sometimes fish, but it's an acquired taste or smell, should we say? But it's very distinctive, and often when you pull in a grapnel full of aquatic vegetation, you can detect the stonewort even before you've seen it. Some of them encrust lime on the surface, and that's the origin of the name stonewort, because that gives them a crunchy texture with the calcium carbonate that's built up on the surface. But one thing that's consistent between them all are these distinctive fruiting structures, which I will go into in a little while. In terms of things you might confuse it with, probably the thing that most often comes up is hornwort. You can see that there is a general similarity in appearance, in that these two have leaves and whorls, and you can see that they're forked as they are particularly in the Nitellas. Completely different cell structure, and we'll have some close-ups of Nitellas, and you'll see that it's a very simple cell structure, whereas hornwort has a much more solid, opaque cell structure, much smaller cells. And the other thing about hornworts, which you can't see in this picture, is that they have little spiny teeth all the way up the leaves. But one of the distinctive things about stoneworts are these fruiting structures. So at the bottom here we have the male, which look a little bit like footballs. They're about 0.5 millimeter in diameter, and inside those, when these mature, they burst open and release little motile anthrozoids, and these swim to the female, which is the oospore, and they actually swim in the crown at the top and fertilize the spore. And at that point, the spores become mature. So the spores are very distinctive. They have these spiral cells going around them. Now that's very unusual in the algae. Most algae just have naked spores. So to have a covering of cells is more or less unique. Also, another thing that's fairly unique about charophytes is that the the spore, when the anthrozoids have swum in there, it's a fertilized spore, and the technical term for that is an oospore. So the spore is the diploid phase. If those of you familiar with the alternating phases of lower plants, so the spore is the diploid phase and is the only diploid part. So all the green parts of the plant are haploid. The way the sort of the fact that these spores are covered, and the way the anthrozoids swim in the top here is slightly reminiscent of what develops later, much more complex things in the vascular plants. And in fact, the stoneworts are regarded as an intermediate, a missing link between the algae and the flowering plants. And I think this is confirmed by, I don't know the details, but I think the chlorophyll also points to a connection between the two. They are a very ancient group. You can find things which are suggested to be stoneworts going right back at least to the Devonian period, so that's 400 million years ago. And I think you can see here something that looks a bit like what we will see later in terms of a Nitella. And this is probably the sort of environment they were growing in, particularly in this Rhine area, which is where these came from, with sort of little pools and not too dissimilar from some of the sites we can find them in today. The spores with that distinctive spiral covering goes back all the way back. So you can see similar things in the fossil record and looking very similar all the way back to the Devonian. There's only one difference. If you look nowadays and most recent times, you'll see that the spores always rotate to spiral to the left. So if you're looking, say, from the bottom, they spiral away from you to the left. Way back in the Devonian, there are a few that spiral to the right, but all these right-hand twisting spores disappear really quite early on, and it's the left-hand ones that have survived to the present day. Just to say a few things about the books. The most easily cheaply available is the BSBI handbook. It's needs some revision. Now I need to say at this point that the taxonomy of charophytes, stoneworts, has been more or less settled since 1850. And has changed very little since, except that during the 1960s, somebody came along and did a world monograph on stoneworts, and completely changed the taxonomy and started lumping things together in a big way. And so there were things that we were now called, which we consider to be good species, were lumped together into effectively super species, and the terminology for some of these, what we consider now as species and were considered before as species, had 4 tiers of names. There was Chara, Hispida, subspecies Hispida, var Hispida, forma rudis, and it just made a complete mouthful of it. And gradually, things have reverted to back to the taxonomy that was in use before. And unfortunately, this has actually made it look as though the taxonomy of stoneworts is unstable, but actually it's been perfectly stable for over 150 years. Unfortunately, the handbook was written at a time when we were only sort of halfway back to the old species concepts. And you will find in the handbook there are some at least Jenny Moore, Bryant did reduce them to 2 levels for species and varieties, but there are some varieties in there which are perfectly good species, and other varieties which are what they say they are varieties. So one of the things, if you do get a handbook, is just to go through, and you'll find in the key that Sarah referred to, that's on the website, you'll see associated with that a list of the names in the Charophyte handbook and in older books, and what they are now. So you might need to go with a pencil and just mark what the species are now. You will find the completely up-to-date nomenclature in the British freshwater algal flora of the British Isles. This is a mighty tome which will set you back quite a long way. It's very good, very comprehensive for all groups of algae, and there is a good section there on stoneworts, but it's quite expensive. There are 1 or 2 other things which I think need to be improved in the Charophyte handbook. One is particularly that I think there's scope for more discussion about differences between the different species and the species descriptions. But if you can get hold of this book, which is written in 2 volumes, 1920 and 24, Ray Society, it's British Charophyta, and written by Groves and Bullet Webster. There's a lot more discussion about what you might confuse it with, and these are the characters, and these are the variations to look out for. So it's definitely well worth, it's still a very useful book, even though it's now 100 years old. I should say that we will put details of these books on the website, in the BSBI website. There is another little book which is not very often seen, but it's very good and readable and interesting. It's a very thin book. It was by Geoffrey Allen, who was the leading expert on stoneworts during the 40s and 50s. And it's also a nice book. Elsewhere in Europe, there are a number of very good books. I've shown these 2 particularly because this Polish Charophytes is available. You can download it online, and it's also in English, which if anybody's experienced Polish, is a definite boon. But it has lots of nice pictures, and I think we would certainly recommend that. This one, which is the French Mediterranean, has some very lovely pictures, and you'll actually see a number of those pictures later on in this presentation. There is also a very comprehensive German flora, which I don't have a picture of here. It is in German, and it's very thorough and complete, and is also an excellent book, but probably not where I would start if you're just getting into stonewort. Now, another, actually, just if I go back a slide or a couple of slides, one other thing I was going to say about the Chara handbook is, you remember I was saying that in the Devonian there were spores that spiral to the right, but now they all spiral to the left. Well, in fact, on the cover of the Stonewort handbook, you do have a Devonian spore. You can see that it's spiraling to the right. Now, some of the keys that you'll come across start you off with a microscopic character, and you can do an awful lot in the field with just a hand lens, and you don't need to get the microscope right at the beginning. So over the years, I've developed a field key which covers the common species, or anything that's not red listed, and that's the key that you will see available on the BSBI website, and we'll be sort of working through some of the characters in that key in the rest of this presentation. It's designed to be on 2 sides of A4, so you can laminate them and take them out in the field, and I think you'll find it's quite a lot easier to use than the keys in the, for example, in the BSBI handbook. So there are 33 species in Britain and Ireland, and the main point of this slide is to really show that there are actually only half of these that are at all frequent. Most of them are extremely rare, and this shows just that over half of them are red listed in both in Britain and in Ireland. So it means that there's quite a manageable number, even including the rare ones. But if you for the moment just get your head around the more common ones, you're only dealing with about 15 species to or less, which is quite an easy manageable number. So although stoneworts do have a bit of a reputation for being quite difficult, actually, if you focus on these more well, the not rare ones, they are a fairly easy group to do, and a lot can be done in the field without any need for taking them back home if you've just got a good hand lens. Also, quite a potentially useful book is the Red Data Book, Red Data Book for Britain and Ireland, that covered lower plants. It's also unique, I think, in covering both Britain and Ireland in the same Red Data Book. You will find actually in that a full key, sort of field aimed key, whereas the ones that I just showed you a moment ago just cover the common species. This will, the key in here will cover everything. And I think it was originally written in 1992, but I think it is still available. So we'll come to the main purpose of this presentation, which is to look at the characters that you would use to identify them and take you some way towards how to go about identifying it. And one of the things that you look at is what is called cortex. Now, in some species, you'll see that it's almost like looking like through a glass bottom. That's because each of these is a single cell. So that internode is a single cell. That's a single cell. They're very large cells, and in fact, you get the largest plant cells in stoneworts. Sometimes up to 20 centimeters long and 2 or 3 millimeters diameter. And for that reason, charophytes were, you will actually find them in old textbooks because of these large cells, that things like cyclosis, the way cell contents move around in cells, were first observed in charophytes, just simply because the cells were very big and you could see what was going on much more easily. These ones on the right don't have anything else. They just have these very simple cells. In this one on the left, there is a similar central cell, but around that are these extra cells which run down, up and down the stem, and this is what we call cortex. And if it has cortex, then it's a Chara. If it doesn't have cortex, it will be most likely either a Nitella or a Tolipella. But there are these two other ones, Lamprophthalmium and Nitolopsis, which are rare genera with just a single species in each. So this is the first thing you look at. Does it have stripes on the stem, or is it just a plain simple cell like looking through a glass bottom? These will generally look more opaque, whereas these look rather glassy. So if we go around the Chara direction, so we've got stem cortex, these stripes on the stem. The next thing to look at is whether there are spines and stipulodes. Deal with the spines first. You will only find those on the main stem, is where you look for those. You can see here there's a bit of a branch that's well coming off, and there are little extra cells around the fruiting structures. Those don't count as spines. What we're looking for are things like these sticking out from the main stem. And what you're looking for with these is, first of all, whether they're developed. These ones are very small, but they are developed, but there are some where you just get little bumps for spine cells, and some where there's hardly anything at all in terms of spine cell. Secondly, you're looking at whether, if they are developed, whether they're sharply pointed or whether they're blunt, and thirdly, whether they're in groups, often sort of 3 or 4, or whether they're coming out singly. And that will take you a long way towards identifying the species. The other character, the stipulodes, now these are, well, just underneath in the armpit, underneath the whorls of branchlets, you get usually 2 cells end to end, one pointing up and one pointing down. These are called stipulodes, and they're often quite similar to in development to the spines in these more spiny species, but they become particularly useful in these ones with very little in the way of spines, because you can see normally there are 2 rows, but in this there's just the 1 row developed. This is Chara virgata, and in this one they're hardly developed at all. This is Chara globularis. So they come into play in these not very spiny ones. Just to show some examples, you have both of these are classify as being sharp spined, very sort of acute tips to the spines. This one, that you can see that they're in groups. You can see one coming out there and another one coming out there. Also here you can see there are several coming out from the same point. So these are clustered spines, whereas here they're just coming out one at a time, singly down the stem. By contrast, this one has blunt tip spines, and they're single. Whereas this one here, which is Chara globularis, has virtually nothing. If you look very closely, that is probably a spine cell there. But to all intents and purposes, they're invisible. And you can see again here the stipulodes are just little round balls, hardly developed at all. Whereas up here you can see, not so clearly, but you can see that there is a sort of little collar of stipulodes, and in fact both sets are developed there. So the next thing to look at, and this becomes particularly important in these not very spiny ones, or if they have spines, they're single and blunt. And there are 4 species in this group, and these are the characters that you'll find if you look in the handbook. Is the first question, and I think that it's much better to look at the spine development as a first step, and only then, because this is not a character that you can really do in the field. You can with practice. I can often do them in the field, but particularly to start with, you'll need to bring them back and look at them under a viewing microscope to just have a clearer view. And what you're looking at are variations in the cortex. Now you can see here, and perhaps clearer here, there are rows with spines and there are blank rows without any spines. And the terminology is that the ones with the spines are called the primary cortex, and they're always the same number as the whorls, number of branches in the whorls. Those, they develop originally from the nodal cells. They extend downwards to cover in the actual formation when the plants are growing. They extend downwards and they meet with primary rows coming up, and then branching off from those, you get these blank rows, which are called secondary cortex. And in many species, there is just 1 row between each of the primary rows, but there are another group of species where there are 2 rows between. So the repeat here is you've got 1 row with just spine bumps here, and then you've got 2 blank rows, and the next one with the spine bumps. So this is a sort of triple cortex, and this is a double cortex, and you will come across some rather jargon terms. The technical description of this is triplosticus, and diplosticus for this double cortex. But I prefer to use double cortex, it's much more understandable. The other feature that we're looking at here is you'll see that in this one, which is the same as this here, it looks as though the spine cells are coming out of the furrows. And that's because the primary rows are actually much narrower than the secondary ones in between. And this contrasts between Chara contraria, where it looks like the spine cells are coming out of the ridges of the stem, because it's the primary rows that are much bigger than the blank rows in between the secondary cortex. And you can see here also, it's a feature of Chara variegata, is that the blank rows, the two in this case, tend to be narrower than the ones with the spine cells, and this is what we're looking at here. You can see a little spine bump there on that row, and another one there on that row, and they're slightly fatter than the ones in between, which are the secondary cortex. So this is a triple cortex species with the spines on the ridges, whereas this is a double cortex species with the spines and the furrows. A little bit fiddly, this probably the most difficult feature to look at in the stoneworts, but once you get the hang of them, it's not too difficult. There is one species, a rare species, Characanescens, the bearded stonewort, where the spines come out of every row. So there are no blank secondary cortical rows in this species. The result is actually that the stem, instead of being green and fairly opaque, it tends to be much more translucent because it's got fewer cells forming the stem. It tends to be a sort of milky translucent stem, and that can be quite a useful character for separating it from similar species. This is also a rather unique species in that in Britain and Ireland you only get female plants. It's a parthenogenetic species, so it self-fertilizes, and you have to go to Southeast Europe, I think, is the nearest place that you will get male versions of the species. Fruiting structures don't get used an awful lot for separating the different species. Size comes into it in one or two of the rarer species, but possibly most useful character about the fruiting structures is that some species are monoecious, in other words, they have male and female together, whereas others are dioecious and the male and female are on separate plants. Now, there is always the issue, particularly because the male tend to mature earlier than the female. How do you know that you've got a dioecious species as opposed to a monoecious species where the either the male part, the antheridia, have disappeared because it's later in the season, or because the spore hasn't developed properly yet. And there are ways of telling that. The main thing, particularly within the male plant, is that you see that the antheridia is centered very squarely on the node of the branches. So we're looking at these little dots on the branches, so the male is sort of centered on the node, and whereas in the monoecious species, even before the spore is developed, the male antheridia are sited just below the node, sort of obliquely below the node. So if you've got male plants, they're relatively easy to separate from each other. Female plants are more difficult. There is an extra cell in the dioecious female plant underneath, which replaces the antheridia, but that's a pretty difficult thing to see. But so I think I've got some examples. So here we have Chara conivens, which is a dioecious species, and you can see there's the node of the branchlet, and there's the antheridia sitting straight square on the node. Now this one is a monoecious species, and you can see that the spores are beginning to develop there, but even before they've even developed that far, you'll find that the antheridia, the male, is slightly just obliquely below the node. So that's does come in useful. As I say, the female has this extra cell, but this is quite difficult to discern, and I myself have difficulty being confident that that's the extra cell as opposed to the bract cells around the fruit. There are people that can separate species based on the spores. These are the spores without the spiral cells on them. They've been sort of scuffed off, and you're left with this dark central part, which is the mature spore, oospore. And you can use the number of ridges on the and the height of the ridges, and you can get quite a long way to identifying the species. It's not something I've done a lot of, but if you're looking at peat cores, you can do, because often these are well preserved in peat cores, you can go quite a long way to identifying what species they are. There is, if you want to go further, there are differences in the patterning on the surface of the spore, but that's a scanning electron microscope level thing. Other things that are useful, there are a few species that produce these little bulbils. These are on the rhizoids. Stoneworts they're algae, they're not vascular, they don't have a proper root system, but they do have an anchorage of rhizoids which help to hold the plant in position in the water on substrate. And around these rhizoids there are a few species that produce these vegetative propagules, these bulbils, and these will grow into new plants when the conditions are right next year. They're often simple celled things in the species that have them, looking a little bit like slugs' eggs. They're about sort of 0.5 millimeter in diameter. But there are a few species which have multiple cell bulbils, and there's a very useful character for those species. A particular thing in West Cornwall called the strawberry stonewort, where the bulbils are supposed to look like strawberries with a bit of imagination, but that's because they're multi-celled. Just to recap on the Charas, there are 9 species that are not red listed that are sort of reasonably widespread, and they divide into 3 groups. There are 3 large spiny species. There are 2 small spiny species, and there are 4 which are small to medium in size, and they either don't have spines, or if they do, they're single and blunt spines. So very quickly and easily, you can put them in those 3 groups. the large spiny ones are even very easy to do in the field. So the three species are Chara culeata, Chara hispida, and Chara rudis. And in Chara culeata, the spines are very dense and persist all the way down the stem. So much so that it's actually very difficult to see the stem in amongst the spines. Whereas in these two, the stem between is usually quite easily visible. They're much more distantly spread. This is actually quite a spiny one for Hispida. Often there's a much more bare stem between the spines. And similarly in Chara rudis, and the difference between these two is that you'll see here the spines are quite slender and they're always pointing towards the center of the internode, at least the major ones. You might get the odd one that's pointing backwards, but if you see here, they're also sort of sticking out from the stem to some extent, so angled out from the stem. Whereas in Chara rudis, the spines are flat to the stem, and you'll see that they're either sort of these are actually two spines end to end, and you'll find one spine pointing towards the center of the internode and one pointing away. And sometimes if you've got three spines, you get this very typical Y shape. But so, and here you can see again, they're pointing in opposite directions. And they're much flatter to the stem. So those are, they're big anyway, so these features are quite easy to see. We're talking about this being a couple of millimeters in diameter across the stem, which is quite a good judge of stature, is the actual stem diameter. Whereas in the next group, these are much more slender species. So we're talking about maybe 1/2 to 3/4 millimeter diameter for this stem, but they're still very obviously sharply spined species. The difference between the two of these is a bit more subtle to do in the field, but no problem under a viewing microscope. Simply the difference is that in Chara aspera, the spines come out singly from the stem, whereas in Chara curta, you can see here, it's a little bit blurred, this picture, but you can sort of see a little cluster of spines coming out together. So if it has simple spines, single spines, then it's Chara aspera, and if it has grouped spines, then it's Chara curta. Chara curta is very much, has its stronghold in Ireland. It's quite a common plant particularly in the central limestone lakes, and relatively much rarer when you get into mainland Europe. And so we're left with the four species that have much less in the way of spines, or if they do, then they're blunt and single. And we've already run through these characters before. You're looking for whether the spines are in the furrows or on the ridges, or where they're hardly developed at all. And you're looking for the number of stripes on the stem, and you're looking at the stipulates. But I've covered that already, so I won't go into a lot more detail on that. I would just add, though, that between Chara vulgaris and Chara contraria, if spines are reasonably developed, they tend to be quite oppressed in vulgaris, whereas they tend to stick out from the stem much more in Chara contraria. So that is something that you can often see in the field, and that can help to pick out the difference between the two, because they do look quite similar in appearance. So we come now to the groups that don't have those stripes on the stem. And there are two main tax genera, which are Nitella and Tolipella. And essentially the difference between the two is that in Nitellas, the branching is furcate, there's forked branching, so equal strength at each division. Whereas in Tolipella, the branching is pinnate. In other words, you've got a main strong central division and smaller lateral ones coming off the side. That can be a little bit difficult to see the branching, but just to sort of set the scene, that's the essential difference between the two. There are some differences in the spores as well, but so here we've got a Nitella, and you can see that these are forked branchlets. Sometimes two, sometimes three, sometimes in some species you can actually get more than three, but usually two or three at each fork. And here we have a Tolipella, and it's a bit more difficult to see because this is very typical of Tolipella. You get these very dense heads. You do sometimes get them in Nitella, but it's particularly a feature of Tolipella. And in fact, what happens is that when they mature, the stems will rot away quite quickly, and you're left with this little ball which can roll around and be distributed in the wave wash. But it is a bit more difficult to see. But I think, for example, here you can see a branchlets, and you've got the main one coming right around here, the strong main division, and then you've got lateral ones coming off, which are smaller, coming off the side. But the main thing to look at in all of these is to look at the tips of the branches. We'll come to the Nitellas and Tolipellas again, but at this point I just want to bring in this one, Nitella translucens, because this one doesn't look at first glance as though it's forked. You'll find that these swirls look as though they're simple, and it's only when you get a hand lens looking at the tips of these that you'll see that they're actually a little crown of very abbreviated forks. And this is distinctive of the species. It's the largest of the Nitellas, Nitella translucens, so this is one of the ones where you get cells. This is a single cell, which can be up to 20 centimeters long. But tips are also important in the other ones, and what you're looking at in Nitella particularly is whether from the last division, from that fork, whether this is a single cell all the way to the tip, or whether there's the tip is actually made up of an extra cell. The way this is drawn, it actually looks as though there's an extra cell here, but that's just trying to show that there's a curvature. What you're actually looking for is a proper cell division separating the tip. Sometimes there's even a third, so divided into 3 cells. But you're looking essentially at this last segment of the branch that's from the last fork to the tip, and in most of the Nitellas you'll see just a single cell. But there is Nitella mucronata, which is probably on the increase at the moment, and you'll find this extra cell forming the tip. Also, most of the rarer Nitellas have these extra cells as well. In Tolipella, again, the tips are important. And you can see that Tolepella glomerata, which is much the most common one, you'll see it has very rounded tips, but there are a couple of rarer Tolepellas where they're tapered to a very acute tip. And in fact, there are only very few. These are red listed species and extremely rare. And in fact, although I talked about the way they branch as being important between Tolepella and Nitella, in practice, the best way of looking at them is to look at the tips. And the Nitellas always have, to some extent, a point, often quite acute or sort of drawn out point. But they're always distinctly pointed, whereas Tolepella glomerata has this very rounded tip, and that's a lot easier to see very often than whether the branching is forked or pinnate. So just to show some examples, this is Nitella opaca, which is the most common Nitella, and you can sort of see, you can't even see where the divisions, but you've got this single cell, and it's a single cell all the way to the tip. Whereas in Nitella mucronata, you've got this cell junction just before the tip, and the actual tip is made up of an extra cell. The two most common Nitellas are Nitella opaca and Nitella flexus, and unfortunately the only way of separating those two is if they're fertile. And in Nitella opaca is dioecious, so you've got the male on separate plants from the female plants. And unfortunately, for quite particularly the later season, you will be very unlikely to see fertile plants. They tend to stop being fertile around about the beginning of August. So for a lot of the time, you're just having to record this as an aggregate, these simple-celled ones. So these are the ones that don't have the extra cell at the tip. And the aggregate name is after the less common of the two, which is Nitella flexus. So a lot of the time you're recording these as Nitella flexus ag, even though a lot of the time it will be Nitella opaca that you're looking at. So we've just come to, there are the main genera without cortex are Nitella and Tolepella, but there are two rare genera with just single species, and they are Lamprophamnium. The species of Lamprophamnium papulosum. In English, we call it foxtail stonewort, because this is very typical that it has a rather sort of bunch of contracted ends with overlapping, and particularly when well developed, it's supposed to look a bit like a fox's brush. It's exclusively a brackish water species, so you'll only find it in brackish lakes around the coast. And structurally, it looks very similar to Chara, but without stem cortex. So it has stipulodes, just a single row in this case, whereas Nitellas and Tolepellas don't have these stipulodes, just in the armpit under the whorls there. But it has the more horsetail like appearance of the Charas. The other one is a starry stonewort Nitellopsis obtusa, which looks generally like a large Nitella opaca, or it has a pinnate branching, although that's often quite difficult to see, particularly when things start getting broken off. The best place to see it as pinnate branching is if you look at these young internodes before they've opened out properly. But the most distinctive thing is that it produces on the lower stem nodes these very distinctive star-shaped bulbils, not always as regularly star-shaped as these examples, but they are these complex, starchy, whitish bulbils that centered around the lower nodes, and are called, the name starry stonewort comes from these bulbils. For a long time, this species was restricted to a few sites in the Norfolk Broads, but just in the last 20 years or so, it is gradually spread. Still an uncommon species, but it's spread across occasional sites in southern England and Wales, and more recently it has also appeared in the lower Shannon Basin in Ireland, and it does seem to be actively increasing. We're not entirely clear why. It may be because it's been more fertile, which may be a climate-related feature. I should say that if you go to the Great Lakes area of North America, they regard this as a very severe pest species. Whereas here it's an interesting and rare native. There it's probably an introduction, and it's quite a problem in some places. One or two extra tips about identification. First thing is to say the best place to look for characters is the first expanded internode back from the stem tip. There are two reasons for that. One is, particularly if you're looking at Charas, sometimes the spines fall off. If you look at these youngest internodes, that's the best place to look for spine characters. The other thing is that I mentioned earlier about encrusting lime on the surface. That makes it much more difficult to see features of the stem. But that tends to be less at the tips than the freshly grown tips. So if you can find a nice green tip, that stem tip, that's what you want to look at to look at these characters. I find that if you're looking under a viewing microscope, underneath light works best to show up cortex features. And even in the field, if you hold it up to the light, often you can see some of those smaller characters a bit better. Also, if you do have problems with, sometimes you can get some very encrusted, completely coated in calcium carbonate. If you stick it in vinegar for 10 minutes or so, that will dissolve away the carbonate, and you'll be able to see the stem underneath it much more easily. So I was just introducing a few slides to show that there has been at times quite a lot of interest in recording stoneworts. This is the pattern for Ireland, but it's actually quite similar for Britain too, and actually not too dissimilar from some of the flowering plants too, in that there was a very peak in interest around about the last 2 decades of the 19th century, assisted by a good monograph. So there was a good identification guide. and also the Groves brothers and later Groves and Bullock Webster were there to provide guidance and identification. And there was quite a big surge in interest. In Ireland, Prager was very prominent and did a lot of recording of stoneworts. There was then a little bit of a lull for, well, for quite a lot of the 20th century, but there's been a growing interest in recent years. And again, the arrival of the handbook was quite a big boost in terms of making it much easier to identify the with an accessible book. But compared to other algae, they are extremely, they're much the best known in terms of distribution and ecology. And you can see here, this is for Ireland, the distribution, and there's pretty good coverage across the island, and a little bit less, but there are also less lakes here. So there's quite reasonable coverage, and particularly compared to other algae, they're remarkably well known. This is also quite interesting. This is just based on the 10 kilometer squares and which are the rarer ones, and you can see that there are several in Ireland with 14 or more species. But compared to that, Britain, with its much larger area, has only 5 that areas of 10 kilometer squares that are equally rich. And this is a reflection of the extensive limestone in Ireland, and the combination of limestone and peat is actually a very good combination for stoneworts. So that leads me on to discussing a little bit about habitats that are where you would go to find stoneworts. I should also add in at this point that stoneworts are evergreen, so you can survey them throughout the year. Maybe a little bit more difficult in the winter if the water levels are high, but they can be a winter activity as well as a summer. So although we're now into September, you will still be able to find stoneworts right throughout the winter. A common theme that we'll come to is a combination of high lime content, so hard water, lots of calcium carbonate, and clean water. They are very sensitive to nutrient enrichment. And I'll come to that a little bit more later. But that is a common theme of good places to look, combinations where there's calcareous geology or and low levels of nutrients. So one of the main habitats for stoneworts are these calcareous lakes, which are often referred to as marl lakes, and often they will be the dominant vegetation underwater. You'll get forests of Chara in this habitat as the dominant biomass underwater. There are marl lakes. It is worth actually saying that there are different sorts of marl lakes. This is quite a typical one where you, in fact, I think they're often in glacial parts where you get kettle holes, and you've got calcareous water, and they tend to be quite peaty underneath and often quite steeply shelving offshore. But there is a special type. These stony marl lakes are very much a speciality of Ireland. In Britain, there are a few examples. In sort of Malham Tarn, Lismore in sort of Oban, which is and in the Durness limestone area in northwest Scotland, but they're actually quite rare, and even rarer in on mainland Europe. So this is a really special habitat and particularly vulnerable to nutrient enrichment too. But they're characterized by these stony shores with this incrustation of blue-green alga, which form quite a thick crust, often sort of some can be several centimeters thick. And then offshore, you will find large beds of stoneworts dominating the vegetation. They all very important, the clarity of the water. You will often find stoneworts going down to 10 meters, maybe more depth in these lakes. Some other good places to look, particularly in the spring, are these flooded dune slacks, and even dune slacks that are quite vegetated and for most of the year are basically fen. In the period when they're flooded, often you will find stoneworts coming up through not in the denser vegetation, but where it's a bit more open, you'll see stoneworts coming through. So this is a good habitat to look at. Turlochs is another good habitat. Again, the main vegetation of turlochs is fen vegetation, but particularly in the sumps, you will often get quite a range of stoneworts growing in it. It's actually a habitat that these aquatic parts of turlochs is a habitat that hasn't been as well studied as I think it should be. In more populated parts of the country, gravel pits can be an extremely important, not just for stoneworts, for aquatic plants generally, because they are isolated from the main drainage system. And the main drainage system, sad to say, in most parts of the more populated parts of the country, tend to be enriched with nutrients, nitrates and phosphates from agricultural runoff and from sewage treatment, which doesn't always remove the nitrates and phosphates. Whereas gravel pits and limestone quarries also, often the water is much cleaner because it's not connected to the main drainage system. And often you have a much richer aquatic flora as a result. Again, carrying on the same theme of calcareous hard water and clean water, there are a number of species that you get in the wetter parts of calcareous fens, in amongst other taller vegetation. Macha lakes are particularly a feature of Western Ireland and Western Scotland. And what you have here is calcareous sand built up against what are usually quite acid rocks of the main body of the land. And that combination, on one side you've got very acid, often quite acid conditions. On this side you've got calcareous sand. So you have juxtaposed vastly different ecological conditions, and that can make a fascinating range for the aquatic plants. And there are one or two acid lakes as well, which are also particularly for Nitella species. This one's quite a rare one that grows in very unremarkable lakes in more upland parts. There are several species that are restricted to brackish lakes, and this is also very important. All of these are rare species, so this is really quite an important habitat for stonewors. Just to end up, I was going to just talk a bit more about the sort of chemical range, just what I was saying before. Nitellas tend to be in more acid lakes, or acid to neutral lakes, whereas Charas tend to be in more alkaline lakes, with the exception of Chara virgata, which is probably the only Chara you're going to get in the softer waters. But I also wanted to say about nutrients particularly. This is just to illustrate that stoneworts are much more restricted to very low levels of phosphorus. This is presence absence, and actually if you if you're looking at abundance, then the cutoff, this is quite a sharp drop between about 30 and 50 micrograms per liter of calcium or phosphorus, but this is another example where we're looking at some lakes on the border between Southern Ireland and Northern Ireland, and it's quite clear that the good stonewort communities are only in this very low range of phosphorus. And the particular problem for stoneworts is that they are algae. They do need to absorb a lot of their nutrients through the surface, so they're very easily clogged up by other sort of epiphytic algae growing over them. They're also extremely vulnerable to turbidity. They are easily outcompeted by vascular plants. And often in such situations, that's when things like Elodioba, Canadian and Nuttall's waterweed can take over because they have a preferential advantage. So finally, just want to say thanks to the Botanical Society of Britain and Ireland, and particularly Sarah Pearce for organising this seminar, and to National Parks and Wildlife Service for funding to set this up. Also, Chris Carter and Claudia Ferguson-Smythe for a lot of the pictures that you've seen, as well as this French Mediterranean book, which has some really very nice pictures in it. So I have gone on a little bit longer than my allocated hour, but I hope that's been a useful introduction to stoneworts.
Thanks a lot, Nick. That was really, really interesting. We do have a few questions that we'll try to get through. I think we'll start with a few around some of the identification characteristics. So there were a couple of questions around spines. For one, do the spines start smaller and get bigger according to season, or are they always pretty much as you would expect to see them?
If you look in the very young internodes before they've extended, then they're often smaller, and they grow as the internodes extend. Then they grow with them, but they tend to be, by the time you're looking at an expanded internode, they tend to be as developed as they're going to be.
Excellent. And there was a little bit of concern about being able to differentiate the pointiness of spines. Do you have any particular advice on that?
It's always a difficult. You have to just get used to You find different groups. Uh, Sharpness and bluntness is defined in slightly different ways, and you always have the difficulty that even if you look at a needle under a microscope, it actually looks quite blunt. So I mean the blunter ones tend to be quite rounded at the tips, whereas the sharp spine ones tend to be much more needle-like, sort of. But it is, I'm afraid, just a matter of getting used to it.
Practice makes perfect.
I think so. I think so.
When you were talking about the stringier species, there was a question about, is the main stem always obvious in those
Yes,
species?
they're quite, there's quite a clear stem, and yeah, I mean they're quite sort of horsetail-like in appearance. A lot of them, so there is quite a clear stem with these whorls of branchlets. Yeah, it's not like some of the ones where everything seems to come from the same place.
Makes sense. And in the dioecious species, would you expect to find the male and the female individuals occurring side by side, or might they be a bit more spread out?
Yeah, I think I can't say that I've ever particularly looked at sort of distribution, but often you'll pick up one handful, particularly if you're grappling with throwing something and pulling stuff out. Sometimes you'll find one bunch that's full of female plants, and another bunch is full of male plants. You tend to have they tend to grow in clumps, so it's not a matter of them being closely intermixed with each other. Often one clump will be one and one clump will be the other.
Makes sense. Right. We've had a few questions come through as well that hint at people wanting to get out and record, which is always what we want to see.
Yes, indeed.
So could you talk a little bit about the collecting methods?
Yes, that's a good point, because one of the things that it's worth saying is that while vascular plants will often float to the surface, charophytes don't. They have no natural buoyancy. So it means that it's actually really quite unusual for stoneworts to be washed up at the edge of the lake. It's usually only where there's a mass of it just offshore that you find that. So it does much more depend on throwing out a grapnel, which or wading out or from a boat. But they do tend to grow in quantity where they occur. Sometimes they are mixed in smaller amounts amongst other vegetation, but you'll often find sometimes in quite big patches. So if you grapnels is probably the best way of doing that. It's also particularly worth looking in the shallows at the edges of the lake, sort of up to about 1 meter depth. Tends to be a different zone from the main body of the lake beyond 1 meter depth. Once you get beyond 1 meter depth, you're tending to get quite uniform beds of particularly vascular plants, but often in that band up to 1 meter depth, I think because you've got more wave wash, you tend to have a more open community, and quite a number of stoneworts are not particularly competitive. There's some they're quite happily growing as annuals, or if the conditions are right, they will carry on, sort of keep growing throughout the winter. But they tend not to be terribly competitive, particularly if the nutrient levels aren't great. So it is well worth looking in the shallows, and sometimes you may find that they're sort of growing under a bit of alga that's collected around them. So it is worth sort of sticking your hand in and pulling, seeing what comes up.
Thanks for that, Nick.
Okay.
I'd also say that in Nick's talk last week, he talked a bit more about collecting methods and grapnels and how to even make your own grapnel. So you might want to look back at that as well if you're interested. There was a question about whether or not canals make good habitats for stoneworts.
Oh, they do. Absolutely, they do. And particularly in Ireland, the Grand and the Royal canals are really brilliant for stoneworts, right into the centre of Dublin. So if you go out to, let's say, Glasnevin, and walk along the canal there, you have a very good chance of finding stoneworts. Similarly on the Grand Canal, and it's because you have the canal system is bringing water from often quite clean sources right into the middle of the urban areas, and without too much other inputs from agricultural runoff, for example, going into the system. So yes, I think canals are definitely worth exploring. Sort of, and even better so in recent years, the Grand and the Royal canals used to have a lot of herbicides thrown in to keep the vegetation down. But because of EU directives, these aquatic herbicides are now much more restricted, I think even completely banned. And it means that nowadays that to keep the vegetation down for boats, they tend to use cutters to remove the weed. And that has been much better for the stoneworts. And a number of places I've found 8 or so species along these 2 canals. But again, the key thing is they've got to be clean water canals. There are some other canals that I've looked at which the water quality is much less, and again, they're not nearly so good.
Right. You said earlier that you can study stoneworts all year round, but are there some times of year that are better than others?
Usually the limitation is, as much as anything, the weather conditions and the water levels. There are some species which is actually better to do over the winter. Tolepella glomerata is a winter spring annual in a lot of situations. It can grow in deeper water throughout the year, but it's particularly a sort of winter spring species. So it's one of the things to particularly look out for in sand dunes, where again you're looking at essentially temporary water bodies, and so it's but there are other ones, particularly ones where you do need to have them fertile, like sort of Nitellas, and those are better done in the early summer. So it's different things for different species. And actually, going back to the previous question, there is an extremely rare Tolepella intricata, where its only site currently known is right in the middle of Dublin, not too far from the Barge pub, if you know where that is. But you do need to look for it early in the season up to about May, because after that it's disappeared.
Thanks for that. Just need to send people out all year round, really.
Absolutely. But yeah, the main, I have on occasions rare occasions. Well, there was one survey that I did where I had to break the ice to actually and feel under the ice to collect samples. That was perhaps one of the least pleasant surveys that I've done, because the ice wasn't breaking terribly easy, so I was slipping all over the place on the ice, sort of stamping on it to break it, and then sort of putting my hand in the cold water to fish out the stoneworts. But they were all very happily growing under there. So anyway.
I think I'm just going to cut in there and say, from a health and safety point of view, we don't recommend you walking out on frozen lakes.
That's true, and yes, of course, there is always the problem when you're near water of being careful. There is always the risk of falling in, and so do be careful when you're looking around watery sites.
Yeah, and in the follow-up email that everyone will receive tomorrow, there is a link to our general BSBI field safety advice. But
Right.
getting back to stoneworts for the moment,
Yeah.
more specifically, there was a question of, do they form part of a successional vegetation sequence, or are sites pretty stable?
It varies. I mean, they are certainly very good and very quick colonizers. So often they will, if you clear out a pond, for example, you may get a flush of stoneworts if the conditions are right. The other thing that's worth saying is that the spores of stoneworts are extremely durable, like decades, possibly even centuries. They will still remain viable. And there are a number of quite clear examples where ponds have been dug out and rare species have reappeared which haven't been seen for decades. Although they like open conditions without much competition, a number of species, I think their preference is, rather than to move quickly to a new place, some of them just sit and wait for the conditions to come back to them. And there are a number of quite clear examples where we've seen things reappear after a long disappearance, when conditions have been, even in lakes, which have gone through a period when they're not terribly happy in terms of nutrients, and plants have disappeared, when conditions have been restored and the nutrient levels have been lowered, sometimes the charophytes have reappeared. Quite a common pattern is that they will appear quite quickly. I've come across a local quarryman referring to them as surprise weed, just because they appear so quickly after they've sort of dug a hole and it's filled with water. But often they will be replaced by vascular plants in turn, particularly as the more organic build-up in the bottom of a pond or a lake. That will often favour the vascular plants. But having said that, in very low nitrate phosphate but highly calcareous lakes in these marl systems, charophytes will be the dominant and persistent dominant as long as the nutrient levels remain low. And particularly these larger spiny species, they are the stable vegetation that continues indefinitely. So particularly in these stony marl lakes, for example, there are quite clear succession. With depth, you have certain species in the shallows, and then Chara curta in the sort of slightly deeper, and then Chara rudis particularly deeper, and some of the things like Chara denudata is a deep water things. So there are. It depends on the situation, but certainly in these strongly calcareous systems, Charas are the climax vegetation. Also, in some acid systems, you'll find that Nitellas are the climax vegetation.
Right.
But the critical thing is low nutrients.
Right. There are a few more questions. I think a couple of them I'll probably send to you afterwards because we're a bit short on time. But just two to wrap up, I think. How do you keep specimens? And can we send samples somewhere for confirmation?
Yes, there are two places. Well, there are several experts around that you can speak to, but Claudia Ferguson-Smythe and I are joint referees, and both of us are very happy to receive specimens, and you can send them fresh, but do seal the poly bags. Yeah, send them damp rather than floating. Just in a well-sealed poly bag. A number of times the postman has appeared with this rather soggy mess and looking rather disapproving. But alternatively, you can press them, and the best thing to do is to float them out in water and then just gently lift with the piece of paper underneath, and then gently lift the paper out of the water, and then sort of stick them in the drying papers with cooking parchment over so they don't stick to the paper. I did discuss sort of floating out in the previous talk about introduction to aquatic plants, but the other option, if you have it, is to send them pickled in alcohol. But that's sometimes more difficult for people to get hold of the alcohol, although you can use gin, vodka, whiskey even. They're strong enough in alcohol to, and I have had people give up some of their some of their whiskey to send me a specimen, but not many. But usually. It's quite often I get specimens in industrial methylated spirits, but the availability of that is more difficult. So for a lot of people, and the other issue with that is that if long term, pickled material needs more maintenance, whereas pressed material is much more easy to keep in the long term. But either of those options are equally good. There are advantages from pickled material. It's often clearer, easier to see the cortical features, but those are still visible in dried material, just manifested in a slightly different way. So there are pluses and minuses of either, but certainly very happy to look at any material that's collected until you feel more confident, between Claudia and myself. If you send them to Claudia, you'll probably get some very nice pictures of them in return. She's a very good photographer, as you've seen from the talk.
She certainly is. Right. I think we'd better leave it there. I will just say that in terms of referees, anyone who's a BSBI member has access to all of our plant referees covering a huge range of different plant groups. And the details of that are in your yearbook and on the BSBI members webpage. So don't forget that you've got that available to you as well. And I think with that, we'll say thank you very much to Nick for another fantastic presentation. Thank you very much to the National Parks and Wildlife Service for funding these webinars, and I hope you have a lovely weekend. Thank you.